So today we're going to be discussing area under the curve, or the probability that certain scores happen. So we have our regular normal curve here, and this normal curve, everything underneath it tells you what actually happened. So most people got around the mean, and as you get farther out in the standard deviations, less and less people have gotten it, that score or that value, whatever you happen to be measuring. So it tells us the percent of the data that falls above or below two data values. Okay, so two data values, so like let's say between negative two standard deviations and positive two standard deviations. If we do that, 95.5% of the data falls, approximately, if it's a normal curve. So all these people right here, that's not almost 96% of the people fall within those two standard deviations. Okay, so this is how we do it. We need the z-scores, okay, because we think of our mean as 0 and each standard deviation is 1, 2, 3, etc. So we always need our z-scores. If it's not already given, then we have to use our formula. And then we use our calculator. So to do this, to find our area under the curve, we use what's called a normal CDF. So it's under the second option, 2, you hit second, then vars, and then choose option 2, normal CDF, and you have 4 things you have to fill in. If you don't have those 4 things, you have a different kind of calculator, then between each one of these things, you put a comma. Okay? So here we are. Use your calculator to determine the area under the curve. So when we do this one, we want to find how much, so we want area under the curve and the probability. So we know the difference between those two things, and we'll discuss it here. So this is the lower bound, this is the upper bound, and we want all the area that's shaded in between. So our lower bound is -1, our upper bound is 2. These two are always 0 and 1. As it says up here, this is the mean, and this is the standard deviation. Okay, and so we put those in as 0 and 1 because we're using z-scores, and that's what they are. Okay, so we just plug these into our calculator, and when we do, we're going to do 82%. I'm just going to round to the nearest percent. So 82% of the people lie in this area right here, and the probability of getting a score in between those is 0.82. So remember, probability is a number between 0 and 1, and percent is just that times 100. So with this one here, we want to find the area from here to infinity. So how many people get negative 1.86 as their z-score? So that's the lowest possible value. The highest possible value, well, I don't know. We don't put infinity, we actually put like 10, because 10 standard deviations would be ridiculous. And maybe no one lies up there, so we usually use 10 for the upper bound, or if it's a lower bound, we would use yet -10. So when we put these in our calculator, we get around 97% of the people, or 0.97. So for this guy here, what you'll notice is we have two separate areas that we have to find the area. So we want to find this spot and this spot. So it's two different problems. So we have to actually plug in two different things and then add the two together. Okay, so lower bound for this one, so I'm going to infinity in the negative direction, so that's -10. It's an acceptable number. You can use -100, a million, it's going to be the same thing. The upper bound then for this particular one is, I'm on the wrong one, sorry, I was on the wrong one there. I was looking at the bottom. -0.78 and 0.1. Plug these in your calculator and you get 0.217695, etc. When you do this in your calculator for this one here, your lower bound in this case is 1.52. The lowest spot here is 1.52. The upper, we just use 10 and 0.1. So when we put this in our calculator, we get 0.0642. And then when we add them together, we get approximately 28%, or 0.28 for the probability. So what happens if they don't give you a z-score and they give you just mean and standard deviation, well, we convert the z-score. You guys know how to do that from yesterday. So we want the lower bound to be 400. So 400 is our data value. And divide by 100, and we get -1. So that would be our lower bound here. So the other one would be 700. The z-score is 700 minus 500, just using your formula from yesterday. And this would be a +2, so this is our upper bound, and we fill it in. Now we don't have to show a lot of work here, but we do have to state our lower bound, our upper bound, our mu, and our whatever the hell that thing is, 1. Okay, so when we do this, we get about, they're asking for the percent, so we multiply what we get by 100. Now, unfortunately, I forgot to tell you where to round to, so when they don't tell you where to round, just got to put everything that you got. Yeah, my bad. So what probability that a random number chosen score is below 249? Well, I don't know what that is as a z-score, and that's what I need. So my z-score will be 249 minus 500 divided by 100. So that is -2.51. That means it's below the mean here, pretty low. And I'm going to guess there's not going to be a whole lot of value. And we're looking for probability here. So we just leave the decimal value. So we have to state the lower bound. So we're going here to infinity, so that would be -10. The upper bound would be -251. Then we get this guy is 0 and this guy is 1. Plug it in, and we wind up getting 0.006, I believe, unless I wrote it down wrong. So when it's a probability, we leave it as a decimal. Probability can be represented as a percent also, but they just have to ask you. When I just ask you probability, you put it like that. Okay, they want to know if a score, the probability, so again, it's going to be a decimal, that the score is less than 249 or greater than 700. Well, we just figured both of those out. The z-score for 249 was 2.51. -2.51. It was right here, and we had to figure out that. And 700 we figured out in the top one. 700 was 2 standard deviations. So we want to know the values from all these to all these. So we just need to figure it out. So for 249, the lower bound is -10. The upper bound is -2.51, because we're just looking for areas going that way. So this guy is 0, this guy is 1. Figure that out, and you get what we did right here. Okay, and then for 700, greater than 700, this one is less than 249. Okay, we get greater than 700, so we want the lower bound is going to be our 700 z-score, which is 2. Our upper bound is 10. These two are 0 and 1. So when we put these in, we get 0.0227, not a whole lot of people. We add these two together, and we get the total number of people, which is, I'll put it in a different color, 0.028786636 something, 7 maybe. Okay, as our area under the curve. So both this one and this one added together, we get about 0.03 approximately. So the probability that you get a score in really, really high or really, really low is only about 3%. Have a good day.